Objective 5. Use the discriminant to determine the number and types of solutions of a quadratic function or equation. Alright, in this objective we're going to go over what the discriminant is. I'm going to do an example. If I'm given a quadratic equation, can I find the discriminant? And then we're going to reference this chart to tell us how many solutions exist and what types of solutions they are, okay? So whatever the discriminant is, whatever we find to be the discriminant, there are going to be 4 situations that occur based on what the discriminant is, all right? So keep that in mind as you're working through this process. First, to begin, what is the discriminant? The discriminant is a value from the quadratic formula that'll determine the number and types of solutions that exist, all right? So the discriminant, I'm going to circle this. First, this is the quadratic formula. We haven't talked about it in this class yet. This is the first time I'm referencing it, but you have seen this before from Algebra 1. Quadratic formula is a formula that's been derived that will help you solve any quadratic equation that is given to you, all right? So if you don't remember how to factor, or if you don't remember how to solve by taking the square root or another strategy we've talked about, then the quadratic formula will always solve quadratic equations for you. Now, I teach it last in this process because if you notice opposite b plus or minus square root of b squared minus 4ac all over 2a, it can get a little complicated, all right, just working with different signs and numbers. And so, all right, there's just room for errors to be made. And so I'd like you to master the factoring strategies first because they're a little bit simpler and they go by a little bit quicker. But when in doubt, you can always use the quadratic formula. We're going to practice that in the next objective. Now, the discriminant is very important from the quadratic formula because, again, it'll help us determine the type and number of solutions. The discriminant, then, all that being said, are the values that exist underneath the radical, all right? They do not include the radical. The discriminant does not include the radical. It includes the numbers that exist underneath the radical, all right? So I'm going to write 2 things. First off, the formula is b squared minus 4ac. So when you simplify whatever those values are, that'll give you the discriminant, all right? So I'm going to also put the number that exists under the radical after you simplify it, all right? So keep that in mind. That is what the discriminant is. And I'm going to label the discriminant just with a D, all right? D is the discriminant. Now, I'm going to do an example of how to find the discriminant. Keep it in mind that whatever I find for my value, I'm going to reference this chart here. So I'll ask you to do the same thing until you get more of the hang of this. This chart here will tell me how many types of solutions and what type they actually are, all right? So you need 2 things for your answers to satisfy this objective. You need to give me a value of what the discriminant is, and based off that value, what type of solutions and how many they are, all right? So this example, if I was going to do this example, I've listed the steps that I'm going to take to satisfy this situation. The first step is going to be put equation into standard form. That's the first step for any process in Module 3. Right now this equation is not in standard form. I know that to be true because it equals numbers and letters. It's supposed to equal 0 on the right-hand side. Right now it doesn't. It equals -4 plus 8x. So that'll tell me that I have to move both the -4 and the 8x. And if you notice, my A term is already satisfied on the left-hand side. It doesn't need to move. My C term is unhappy on the right-hand side. And my B term is also unhappy on the right-hand side. So I need to move both my C and my B term. Now, in order to move the C, it's a -4, so I add 4. In order to move the B, it's a +8, so I subtract 8x. Positive 8x. Whatever I do to one side, I have to do to the other side, so I +4 and -8x. And I do that whole situation because now this cancels out, and it's going to equal 0 on the right-hand side. Now let's clean up the left-hand side, write it in standard form. With my quadratic term first, which is the A term, is 4x squared. Then my linear term, or the B term, it was an 8x on the right-hand side, but I subtracted it over to its home in the left-hand side, so it's -8x. Goes next after the quadratic term, and then +4 for my C term. If you notice, it's +4 and -8x. So now it is in standard form. I'm done with step 1. Step 2 states to identify the values for A, B, and C. And if you notice, it's very important to do step 1, get it in the standard form, because if you didn't, then your C and B terms would be wrong. But now they are correct because they are in standard form. So step 2, my A is 4, my B is -8, and my C is 4. All right? I'm done with step 2. I've identified A, B, and C. Now, step 3 says to put the values into the formula for the discriminant. And we've identified the formula to be B squared minus 4AC. So step 3, I'll change colors. And I'll write that formula to reference in B squared minus 4AC. My B, if you notice, the B is being squared. Anytime there's a variable that has a power with it, please put whatever value you're going to input into that variable in parentheses, all right? So my B squared, I need to put in parentheses, and my B squared is -8. So my B is -8. So -8 squared, all right? That's just going to help the calculator know what number is squared if you put it in parentheses. So I've done that correctly. Minus 4 is a constant in this formula. My A term, which is also 4, and my C term, which is also 4. All right, once I do this math, this step 3 is going to give me the discriminant, all right? So I'm going to input this exactly like I see it in my calculator, and it spits out 0. So I have done step 3. I've put the values into the formula, and technically I've already done step 4 as well. I have simplified the discriminant, and I have found the discriminant to be equal to 0. All right? I've done that with my calculator. Now, step 4 has another piece as well. Remember, I said we have to reference this table down here once we find the discriminant. There are 4 situations that occur. We have encountered the third situation. I have found my discriminant to be 0. That tells me that there is one real rational root. All right, so I have to include that in my answer as well. One real, that looks like an N, meal. One real rational root. At this point, after finding the discriminant, the number value for it, and then stating what types of solutions and how many they are, I am done with this problem. Let's talk real quickly before you try some of these on your own. The other situations that occur, if D is greater than 0, and it's a perfect square, you will have 2 real rational roots, all right? And if you remember perfect squares, some examples of them are 4, 16, 9, 25, 49, all right? Because if you take the square root of those numbers, you get a whole number. Square root of 4 is 2, square root of 16 is 4, and so on, all right? If that situation occurs, if D equals something like this, then you'll have 2 real rational roots, all right? Now again, to check that, all you do on your calculator is take the square root of whatever D is, and if it comes out to be a whole number, you know that it's a perfect square. Now the other situations, if D is greater than 0 as well, but it's not a perfect square, so basically any other positive number that isn't a perfect square, and again you check that by taking the square root. If it doesn't come out to be a whole number, then it is not a perfect square. You will have this situation, 2 real irrational roots, all right? And we've discovered the third situation in this video. And then finally, the other situation that occurs, if D is less than 0, meaning that it's a negative number. If you remember, you can't take the square root of a negative, so you have an imaginary solution, and we're going to call this 2 complex roots. Complex meaning that it's a complex conjugate, meaning that there's going to be a whole number plus or minus a number with an I in it, or imaginary number, all right? Whole number plus or minus an imaginary number. These are examples of graphs you would see. If they're greater than 0, it's a perfect square, meaning that your numbers will be real and rational, so they'll cross the x-axis at whole numbers. If you have irrational, they'll cross the x-axis, but they won't hit whole numbers. Remember, they'll be in between because you'll have a decimal. If D is 0, it'll be a real rational root, but there's only one of them because this is a special situation where it'll bounce off the x-axis. So in this case, x equals 5. but really that 5 exists twice. It is a double root. And we'll talk more about that. And then finally, if it's less than 0, they're imaginary, meaning they don't cross the x-axis. So at this time, would you go ahead and please try 6 of these problems on your own? And I have the answer key. So after you're done with these 6 and you find the discriminant and tell me what types of solutions exist, please check your work, and your goal should be mastery at 6 out of 6.